Let's get into limits. So when studying a function, y equals f of x, we find ourselves interested in not just plugging in x values and getting out y values, but we find ourselves interested in f's behavior near an x value, not just at the x value. Because some x values we can't plug in. They make us divide by 0 and they make the graph go in all sorts of directions. And so it's not helpful to plug in and divide by 0 and not know what happens. And so let's plug in a number near. So let's say if we plug in 4, it makes us divide by 0. Well, let's plug in 3.9 and 4.1 and see what happens near that x value that we weren't able to plug in. That's the idea of a limit. So we have some new notation, which is kind of intimidating. We're going to learn and break it down. We're going to say that, and it's going to be written LIM, which stands for limit, and then it has an X arrow C underneath, which how I would read that is the limit as X goes to C or as X approaches C. So normally there's going to be a number in there. So in this case that I just said, it would be the limit as X approaches 4. Of f of x, means we're going to plug in to the function, equals L. We would say the limit as x approaches C of f of x is L. So that means when x is near C, but different from C, then f of x, which remember is the y value, is near L. That capital L is called the limit of the function f. So instead of plugging in an x and getting out a y, we're plugging in a number near x. So instead of plugging in 4 and saying, well, when I plug in 4, it makes me divide by 0, I'm going to plug in 3.9 and see, well, the y value when I plug in 3.9 is 6. And then when I plug in 4.1, I also get 6. So the limit as x goes to 4 is approximately 6. I'm not allowed to plug it in because it made me divide by 0. But when I plug in 3.9 and 4.1, I get 6. So I'm just going to say the limit as x approaches 4 is 6. All right. So our answer, these limits are just the y value. The limit L is the y value. We're reading a graph and saying, well, I know the x value I want to get close to. And figuring out the answer is just what y value do you get close to. So a limit does not exist if the function approaches different values from the left compared to the right. So in that example I gave you, I said we're plugging in 4, but we're not allowed to. It made us plug in 0, so we're going to plug in 3.9 and 4.1. Those are both near 4, but one's on the left and one's on the right. So if, for instance, if I plug in 3.9 and my y value is up at 10, and then I plug in 4.1 and the y value is down at -2. If plugging a number near 4 on the left and then near 4 on the right don't get me to the exact same y value, we don't just pick our favorite number, we say the limit does not exist. So even if we don't have a two-sided limit, we can still have a one-sided limit though. So let's give those definitions and then we'll look at a picture and it'll make a lot more sense than hearing all these words and not seeing anything. So for one-sided limits, we're going to get some notation. The function f of x has the, and let's do the left-hand limit first. Coming in and doing our left-hand limit. Which I'm just going to write as LHL most of the time. Left-hand limit is L as x approaches C. How that would be written in math notation, it would say the limit, which is just LIM, as x approaches C still, of f of x. So one difference is, super tiny, to say that we're just coming in from the left-hand side. Well, think about a graph or a number line. The left-hand side, is that the positive numbers or the negative numbers? On the left-hand side is negative numbers. So as you approach C from the negative side, so lim as x approaches C, and then a negative in superscript up there means let's approach C from the left-hand side only. We would say that equals L. That's how we'd write the left-hand limit approaches L as x approaches C. For the other side, the right-hand limit, the right-hand limit, which I'm going to normally call RHL, is called m as x approaches c, how that would be written in math notation would still be that LIM, which means take the limit, as x approaches c, and then we're thinking from the right-hand side. So which side of the graph is the right-hand side? Is that the negative numbers or the positive numbers? It would be the positive numbers. So you put a plus in superscript equals m. Now the reason I use two different letters, L versus M, is that sometimes left-hand limit doesn't equal the right-hand limit, which again means the two-sided limit does not exist. So we have a little space here. We're gonna say, right under here, the limit as x approaches c of f of x equals dne if the left-hand limit, I'm gonna write it out in letters up here, is not equal to the right-hand limit. Or in other words, the limit as x approaches c from the negative side of f of x does not equal the limit as x approaches c from the positive side of f of x. We have to come to the exact same number or else the two-sided limit does not exist. So if you're trying to plug in 4 and you look at the y value for 3.9 and 4.1 and they don't get you to the same exact y value, the two-sided limit is dne. So we don't pick our favorite y value, we just say the limit does not exist. And this will all make so much more sense when we look at some pictures on the next video.